In the beginning, I would like to introduce for a moment Microsoft Austria, and will introduce as well our amazing technology and the opportunities through mixed reality. But be prepared, after a few minutes I actually will invite you to something completely different, and a world where biology, technology and design actually will mix. As we actually just heard in the beginning of the event by the founders of 15 Seconds, digital transformation is really significant, and the digital era is in full progress. This leads to a transition of the established understanding of employees, customers, communication and distribution channels, business connection and its values. Those who take on this digital journey have to pass through a lot of different stages. Currently, most companies are actually still in an early startup stage of digital transformation. Microsoft wants to be here the help and to digitalize Austria and to be the trusted advisor to create the best possible experience for the digital journey of local businesses and assist in digitalizing your business successfully through our products and services. So give me a short examples based on the HoloLens. To keep it simple, we have two universes today. One that is based on atoms and the laws of physics, and one that is based on bits and digital logic. These universes have the corresponding realities, a physical reality and a digital reality. Now, thanks to Windows 10 and its capability to understand you and your world, we can blend these realities, the digital into the physical into the digital, and create what we call a mixed reality. In May 2016, we announced that mixed reality is coming to Windows PCs. The Windows mixed reality technology, combined with the power of the PC, with the latest virtual reality innovation, will enable new mixed reality experiences that are simply not possible to any other platform. This will enable the most complete offering across the widest range of head-mounted displays, ranging from fully immersive virtual reality to fully unethered holographic computing. Let's define first what the mixed reality spectrum actually is. On the left-hand side, we have the physical reality in which we humans exist. And on the right-hand side, we have the corresponding digital reality. Let's say we are in the physical reality on the left. If we start to bring something from the digital, like a digital representation of a person, a place, or any kind of thing, and mix it into the physical, or let's say we are in the digital reality and we bring in anything from the real reality, like a person, a place, or a thing. Then anything between is actually the mixed reality. Sorry. Most AR and VR offerings today represent a very small part of the spectrum. They are, however, a subset of the superset, which is mixed reality more broadly. Windows mixed reality requires that the computer is capable of environment awareness and can be represented by any mix of physical real or digital representations of people, places, or things. There are two main types of devices that deliver Windows mixed reality experiences. The first are holographic devices with see-through lenses like Microsoft HoloLens. The other one are head-mounted ones. At Microsoft, we are building Windows 10 to be the most complete platform across the broadest range of mixed reality devices and experiences. We believe that full-featured mixed reality experiences should be attainable for everyone. The future of computing will blend the physical and the digital worlds to produce new environments where physical and digital objects coexist and can be interacted as if they would be real, freeing you from the two-dimensional rectangular screens that have constrained information for decades. This vision goes beyond an isolated virtual world, where we are unifying the mixed reality ecosystem around an immersive, affordable, and compatible platform that enables shared experiences. But let me give you some examples what that would be enabled. We could use it for creation and design through the ability to see and manipulate 3D designs in real time, in a real world setting, in true size and scale. or for assembly and manufacturing. The ability to synthesize complex data sets and provide visual displays that aid in navigation and operations. Or for communication and understanding, the ability to provide remote expert assistance seen through the eyes of the remote user. Or for entertainment and engagement, the ability to experience entertainment content in more personal and immersive ways. Or for training and development. But let me give you an example for this.
We've been teaching human anatomy the same way for 100 years. Students get a cadaver, then they look at medical illustrations, and it's completely two-dimensional, and the human body isn't.
Microsoft HoloLens is a holographic computer that you wear. It enables you to bring your digital world into your real world.
At Case Western Reserve University, we are focused on solving problems and creating new knowledge.
My job is to teach, and I really think this could impact almost everything that we teach people. With HoloLens, you can see the muscles on top of the skeleton all at the same time. You can bring them in and out and exactly understand where things sit.
You can take any anatomical part and show any of it. You can move it around, you can make it kind of translucent so you can see through the outside, and that really helped me understand how cardiac anatomy worked. I actually had a moment where I found the aortic valve, and it was the first time that I'd actually seen the aortic valve in relation to all the other anatomical structures. It was a way of seeing it that you couldn't do with an actual heart.
I think this will improve students' confidence in learning anatomy dramatically.
By creating simulations with the HoloLens that lets them have an experience where they can fail, that would be the best way to learn, because we don't allow people to fail too much in real-life medicine.
With HoloLens, you could imagine having a class standing around a model, almost like a tour group in a museum, where they're all interacting completely naturally. I spend a huge amount of time to make sure they become the best professionals, because it's all of our jobs to make the world a better place.
Working with Case Western Reserve University to create this paradigm shift so that we can leap together with students into the future of education. We believe that HoloLens is going to enable us to do that.
We talked about being able to use it to teach art history. We have an anthropology department too that I think will enjoy this technology.
Anytime you change the way that you see things, it changes the way that you understand them. As soon as you can change somebody's understanding, then they can change the way they see the world.
So please join us later at our Microsoft stand and explore the HoloLens yourself and many more Windows 10 devices. And my colleagues will be also much better in inviting you into full spectrum of mixed reality. Personally, I am inspired by it as a new tie for scientific explorations and education, and that I can not only bridge actually the physical and the digital world, but the artificial and the natural. And I would like to invite you for the rest of my talk to explore with me a side of Microsoft Research, that you're maybe not as aware of. And I might have to prepare you that I'm not a classical Microsoft researcher. So let me introduce myself for a moment. My name is Helene Steiner. I'm currently a postdoc researcher at Microsoft Research and a lecturer at the Royal College of Art. My background is very diverse and uncommon. I used to work in business administration, made my first master in product design actually at the Bauhaus University in Weimar, continued studying with a Master of Art and Master of Science in Innovation Design Engineering at the Royal College of Art and Imperial College, and had the great pleasure to continue to collaborate with the Tangible Media Group at MIT Media Lab and MIT Chemical Engineering before I started as an artist in residence at Microsoft Research and continued as a postdoc researcher. As a result, for me, design, engineering, and science really started to naturally merge in my way of thinking. I see myself as a kind of conductor between the fields, exploring areas that can support each other and inspire to create new pictures, projects, and concepts. And since a while, I'm fascinated by the potential of combining biology, computation, engineering, and design to create impactful and sustainable projects. And if you look back at 2010, disciplines were still fairly siloed. Collaborations were still not really practiced, and interactions between the fields not really seamless. But today the walls between disciplines and fields are blurring. New fields started emerging out of this and enabled so many innovations in the last years. For this, I think it's essential to have someone with collaboration and communication skills, someone who is able to use different vocabulary of fields and has the ability to develop constantly new skills and to evolve with the industry, with research and academia. And design can be here the unifying vehicle to drive the best experience. And I think out of this, a new kind of designer started to emerge, the fusionist. And that is where I see myself. And the challenge and the reward of a fusionist is the ability to communicate, to comprehend and connect all parties through design. And when we look at the global challenges that lie ahead, I think they can be only solved by a collaboration of minds and vocations and a diversity of views. To start my journey, I would like to start with a project before my time at Microsoft. The project that encouraged me actually to bring biology into my work. Project Biologic, was in collaboration with the MIT Media Lab and MIT Chemical Engineering. What it is actually a growing living actuator and a responsive bioskin. The application that you just saw is a garment that reacts to the wearer's body temperature and sweat and supports the body through controlling tiny flaps that open up and close regarding to the wearer's needs. And the technology that enables this is actually bacteria cells. They have an incredible ability to expand and contract depending on the relative humidity in the air. Through applying those bacteria on a substrate material, we were able to actually create shape-changing materials. Those cells, called Bacillus subtilis, if anybody is interested in it, are actually edible and extracted from fermented soya beans, also called natto, if somebody likes Japanese food, but also can be found in soil. They can duplicate themselves, and their exponential growth rate enables the use of growing actuators even on an industrial scale. The exciting part is the sensitivity to its environment. Opens up new biological interfaces without the need of even embedding electronics. We used our skin as the interface that creates a direct interaction between the human body and the bacteria cells. And through researching the female and the male heat and sweat map, we were able to build a software which enabled us to engineer a fully functional garment. The software creates a simulation and feedback loop of the designed material and considers the substrate used underneath. And connected with the hardware platform we built, a bioprinter, we were able to produce our ideas one-to-one and made it accessible for designers, engineers, and scientists. And the creation of this whole platform was only possible because of our collaboration of minds, skill sets, and fields. And enabled us to create many more applications, from shape-changing lamps to animated origami for toys, to artificial plants. But what I'm even more interested in is in how we can bring our environment into our decision-making process. I'm exploring the possibility to not only work with the mechanical properties of bacterial cells, like you just saw in Biologic, but also the processes within a cell. So we began investigating how living plants function. Plants are constantly in communication with the environment and within themselves, actually. They can obviously not move, and because of that, they have to constantly adapt and react to the environment to be able to survive. And one way how they're actually doing that is through electrochemical signals. And with electrical signals, we are actually very familiar. So we began to capture those tiny signals from the surface of the plant with the help of a relatively simple tool we engineered that is not too far away how we actually also capture our own biosignals. and started to look into the patterns generated. The fascinating part is that the electrical patterns are distinct to different abiotic and biotic stress. And this may provide the opportunity to map those patterns to different environmental causes and to find a way to even understand what is happening and translate it in the future. For example, the signal of the triggering and closing of a Venus flytrap captured with our current device. You can see twice we trigger the hair inside the trap and the closing itself. And this signal is always looks the same, so we know even just by looking at the signal what is happening inside a plant. With Project Florence, we wanted to explore if there's also a two-way communication between a plant and a human. So let me quickly show you the video. In this project, we used language as a human input and light frequencies as a plant input, and translated through the help of natural language programming human sentences into different light frequencies and durations, similar to sending a Morse code through a biological organism, and translated the plant's reactions through our device back into human sentences. This project is a first step of exploring to turn on chemical signals in a plant digitally. Here you see, for example, the output of one of our experiments, where we control artificial light over the period of 1 week and measure the changes of variation potentials, or the very tiny electrical changes in a plant caused by ion fluxes, and fluorescence emissions in plants caused by different chemical reactions in a plant. Technology can act here as a translator for biological processes, for applications such as sustainable agriculture. Let me give you an example. We put currently multiple times a year chemical pesticides on our fields. Mostly our plants are actually not infested. Having a technology that allows us to see what is happening in a plant could be a really big game changer for agriculture. And that might all sound very abstract to you, but humans always combine biological processes with progressive technological advancements to produce, process and create. For example, the domestication of plants and animals resulted in human settlements. Our evolution from hunter-gatherers to farmers some 13,000 years ago can be seen as the start of using organisms as tools as well as a fuel. Nevertheless, our actions have affected our natural environment, often negatively, because of the missing consideration of social, cultural and ecological interconnections. At the Royal College of Art, where I teach, me and my scientific collaborator focus on creating curriculums to bring together biological, physical and computer science, and to create collaborations between scientific, anthropological and design disciplines to produce sustainable solutions that support our whole ecosystem. In our projects, we introduce new technologies which open up new opportunities to manipulate, design, understand, protect and interact with our natural environment in sustainable ways. In the last project, we focused on the food supply chain and asked the students to think, define and create new approaches for the future of food. But let me show you quickly a video of it.
We wanted to know if there was a better way to pollinate crops cheaply, effectively, and without bees. We wanted to encourage flies to become more effective pollinators.
Around 200,000 tons of coffee are being thrown away in London, which contribute massively to the urban waste system.
As designers in this field, we are aware of a high rate of textile pollution, which alongside food waste is one of the largest problems in the world. We as fashion and textiles designers wanted to understand our own perspective of food waste and how our practices could intersect with food waste issues.
Astronauts have been trained to adapt to the food system in the space, but for the future space travelers, they're going to be ordinary people like us. It can be very, very difficult for us to adapt a very limited food system.
Oh, it could be really interesting, like design this type of new tableware system in which we use really like 4 dimensions, because you are able to do that in space.
Our gut health, and also its microbial communities have the power to potentially influence how we behave, how we feel, and of course, who we are as a person.
We also believe in the future this could lead to personalized, basically recommendations of probiotic meals to then correct any imbalances in fact, and all the while tracking and analyzing the state.
And we work with food technologists to compile a dossier about preparation methods like temperature, pressure, the texture, the mouthfeel. And then we found a sound designer and violinist who focuses on working with artists, scientists, chefs in galleries to combine avant-garde, classical music, science, and art together.
We need to consider higher level needs. We need to consider what's actually going to help them develop a society and develop a culture, because in the end, culture develops resilience, and that's what takes you through the day in such an extreme place like Mars.
It's not only connecting one balconies or apartment, it can also connect to other balconies. It connects to other apartment. So you can exchange soil mineral with your neighbor. This is not only connecting human to nature, but connecting human to human.
Part of this project was how to teach the intersection of technology and biology and how such biological interfaces might look like. For this, we created a workshop which allows to create your own biopixel display outside the lab with the help of cell-free technology. But let me quickly explain what cell-free systems are. Synthetic biology let us design biological functions for many purposes, meaning we can modify or transform a cell itself to let it produce different products or to let it conduct any kind of functions we would like it to do. But those can be often a hazard or can't be easily done outside the lab, and it can't be ensured that they don't have any further effect. Cell-free expression systems are here truly amazing. Then it uses still the protein producing machinery of a cell, but pulled straight out of a cell. And you might wonder, why the hell would I do that? What is nice about it, it can't reproduce itself anymore because it's outside a cell and technically not a genetically modified organism anymore. This allows applications and experiments outside the lab, like the Royal College of Art, without being any biohazard anymore. The proteins that we used are from these fantastic creatures just behind me, the jellyfish. For this, we created a set of open source hardware and software that allowed the students to design, create, and monitor their own biopixel displays. and to be able to go beyond the common way of handling just tubes and liquids, how it is normally done in the lab, to contextualize the learn through engaging the students in a full process, from designing, planning, handling, monitoring their own biological parts. A simple LED matrix, as you just see, controlled by an app, allows the students to design their 8x8-bit pixel picture, choosing the color. And the color stands for the biological circuits they actually use. And, and there's a big variety of proteins that you actually can use, or that a cell can produce. So we can not only produce any sorts of different colors, we can also produce smells or a lot of drugs, or I can use it for diagnostics to really make a change for medical applications. Our transluminator box not only allows us to excite our biological machinery, but also to monitor, share and compare the biopixels and stream it into the world. Here you see, for example, two different experiments, small ones, where we produced the 8x8-bit pixel display on different materials. One, the upper one, is made of paper actually, with the biological parts, and underneath with more common tools from a biological lab. The software we created allowed us to monitor your designs and creates a feedback loop with the user. And the combination actually of multiple biological circuits with electronical circuits will allow to activate the biological functions through electrical input, like heat shot, controlled light input, or different light frequencies. Meaning I can actually change the color when I want it, or turn it on and off. And everything we teach is open source, because we believe that shared knowledge is really important. So please feel free if you want to test everything yourself. And last but not least, I would like to give you a last example of a display, what is not biological, but maybe a little bit inspired by it. So can I ask how many designers are sitting here at the moment? Good. If you imagine that you have to build your product only with a square, and you're not allowed to cut it, to fold it, to bend it, or to do anything with it. That's pretty much what it is if you currently design with a display. And imagine being able to really constrain by these aspects. And we have currently these absolutely fantastic screens with full color, high resolution. They're getting thinner and bigger, and they're fantastic products. But they are always flat. And they are always rectangular. And they are very fragile. And they are very power hungry. And most of them come with a fluorescent glow and flicker. And it's very hard to really scale them up. They can't really naturally grow. And they are never really seamless. And you need a lot of infrastructure to actually do it. And all of that counts for each single product. It's not only for Microsoft, and it really kind of like guides our interactions. And it defines often even our interior and our architecture. And we can be sure that it's never ergonomic. Our body is not rectangular and will never be. And often there's also the question how appropriate an emissive screen is really on our bodies or in our natural environment. And screens are getting much thinner and flexible, but I think as you can see in the face of the person who tries to bend it, the screen is still not really meant to do that. And there are customized screens that are not rectangular, but they are highly customized. They're very expensive and not made for the common user. So what we did at Microsoft, we looked behind the row column architecture of the common screens. Sorry, I'm losing my microphone. And we wanted to go away from a lateral matrix and a centralized model like our common screens are, and completely turned the architecture upside down. There's no centralized driver anymore. Each single pixel has a driver in itself, and it's smart in itself. So we can decide which input we want to have and which output. So we can choose from different light frequencies, touch, all kind of like everything what a sensor actually can provide us, and can choose from all sorts of display outputs, from OLED to e-ink to many more. What means like that our display is behaving much more like a cell that reacts to a stimuli with a reaction. Here you just saw actually the example of using light as an input and e-ink as an output. So what would enable that? You could, for example, now imagine that you can capture pictures from light-emitting surfaces like your screen. So you can just grab your content and take it offline. And it only needs energy in a moment of change. Or you could imagine now drawing with light. But it also gives it many new physical properties. And we can start now think about a display as a material rather than a device. And we can think that it is produced roll to roll and is flexible and cuttable like a leaf. We got here really inspired by actually fashion and pattern making, where you go from a very simple two-dimensional surface to highly complex three-dimensional shapes. And being able to cut, fold, and transform displays from 2D surfaces into 3D shapes will give designers an entirely new language to express themselves and to integrate them into our everyday lives. What opens up new applications actually from a single pixel, if you just think about an indicator, to a billion of pixels for many different industries. Imagine, for example, for the fashion industry, from the places to occupy to the clothes we wear. I think we live in absolutely fascinating times with endless opportunities to create innovations. And I really do believe that we have to tackle it with interdisciplinary work and shared knowledge. We should make advantage of these opportunities and make them positive and sustainable ones. Through our collaboration of minds, vocations and perspectives, and why not also inviting nature to our discussion. Thank you.